Hi folks, it's Dr. P. In Lab 11, you're going to build a sequence detector that uses input from a keypad to lock or unlock a system. This is a fun circuit because it's very similar to a garage door opener or something else you might use in your everyday life that takes a specific numeric sequence from a keypad to make something work. We're going to break this down into pieces to make it simpler to put together and debug. The first part that we'll work on is the monostable timer. A monostable timer is used to create a pulse of short duration. In this case, it will unlock the system for 4 seconds. After that, the system will time out and go back into the locked state. We'll represent unlocked with a green LED and locked with a red LED. The second part we'll put together is the keypad and display. This should be pretty straightforward as you'll have PCBs that do most of the logic for you already. Third, we'll build the next state logic for the finite state machine and make sure that it works correctly by putting the flip-flop outputs onto LEDs. Finally, we'll build the output logic. Once everything is built, we'll have a fully functioning keypad sequence detector. Ready? Let's do it! This monostable timer takes a low input pulse on the trigger pin and creates a high output pulse of a duration that's set by using particular capacitor and resistor values. Eventually, the input to the trigger pin will be an asynchronous output from the finite state machine. For now, I've used an active low push button just to check that it works. To create an active low signal on the push button, what I've done is I've taken the push button output and fed it through an inverter. When I push the button, the green LED turns on for 4 seconds. The red LED is on every time the green LED is off. I would ideally be using an RGB LED to do this, but I don't have one at home. Now that this works, we can get the keypad set up to display on a 7-segment display. So at this point, we have the keypad and the keypad encoder connected to a display. So all I should really see here is that whatever number I press on the keypad is going to show up on the 7-segment display. I also just put an LED onto the data output pin on the encoder just to kind of have a nice feel for the fact that that's working also, because this is going to be our clock signal. Every time I push a button, that's going to be an indication for my flip-flops that they need to change state or not, depending on the input value. So this should be a very simple process for you. For me, it took some time because I don't have one of those keypad encoder PCBs at home, so I had to hook up the encoder by hand. So for you, it should just be a function of taking that keypad encoder PCB, connecting it to power and ground, and then connecting the ABCD inputs to the ABCD inputs on your 7-segment display PCB. The other thing I want to point out real quick is that the numbers 10 and 11 show up weird on the 7-segment display, and that's because 10 and 11 aren't really supposed to be inputs for a single 7-segment display. So I don't really care what those look like as long as all of the other numbers display the way they should. All right, so let's actually build the finite state machine and put all this stuff together. All right. As I was building the finite state machine, it occurred to me that I could actually break this down into 2 parts. So anytime we can kind of put something into parts, it's better to do it in pieces rather than trying to do everything at once. So what I've done right now is I've created all of the next state logic, but I haven't touched the output. So that trigger is kind of just hanging out, not really connected to anything. So what should happen is, based on your state assignments, I've got both of my outputs from my flip-flops connected to LEDs, so that I can just make sure when I'm pressing the buttons on the keypad that I get the correct state assignments showing up. This is a nice smell check to make sure that things are going well before spending a lot of effort building everything. So what should happen is when I press 5, I should go into state 1, and then when I press 7 after 5, I should go into state 2, and then almost regardless of what I press afterwards, I should go back to the reset state. So this is going to be different depending on what your state assignments are. So when I press 5, I see that I go into a state, and then 7, I go into state 2, and then anything I press, I'm going to go back into my reset state. The only exception is if I hit 5 and then 7 and then hit 5 again, right? Because I'm kind of at the start of my sequence. So this is a nice, again, it's just a smell check, right? I know that my next state logic works, so now I can focus on my trigger logic, my output logic, right? This is floating, so it's not really connected to anything. So once I have that connected, then I'll really have the whole part kind of put together. So let's build that last output logic. Now we have a fully functional sequence detector. So I can press 5, 7, and 3, and my output is going to change to that unlock state, stay there for 4 seconds, and then lock again. So we've got the Monostable Timer, we've got the keypad and the display, we have the next state logic, and we have the output logic. So everything is integrated now. And because we've broken into pieces, it's a lot easier to troubleshoot and debug. So regardless of what I put on the input after 5 and 7, the output is not going to change. The only thing that will cause that unlock to happen is 5, 7, and 3. So we've successfully created a sequence detector using a keypad as an input, again, by just breaking things up into bite-sized chunks so that we can very easily figure out where we've made any mistakes and kind of just to help make the process of building this much smoother. All right, folks, until next time, stay well.